Question number 5. A stone is projected horizontally at time t equal to 0 and falls. So you are standing on a top of a cliff, though it is not given. Okay, so you are projecting it horizontally and it falls. So when it falls, what happens? It falls like this, describing a projectile motion, horizontal projectile. Here resistance is negligible. Stone has a horizontal component of velocity and also a vertical component of velocity. See, when you throw it, it's only a horizontal, and here its vertical was 0. But as it keeps on coming down, it has a horizontal and as well as a vertical. Okay, so which graph shows the variation of VH and VV with time t? So you need to find out which graph in a VT graph over here. So we know that the horizontal velocity always remains a constant. So horizontal velocity is constant here. Here vertical velocity is constant. Wrong. Horizontal velocity is constant. Vertical velocity, horizontal velocity is constant over here. Okay. Then what about the vertical velocity? Vertical velocity keeps on increasing as it comes down, right? So therefore, vertical velocity is increasing here. Here, no, here it's increasing, but in a non-linear fashion, right? See, here it's a non-linear fashion. This is now decreasing. So this is definitely not correct. Now amongst these two, we need to judge equation. What is the equation governing them? We know that V is equal to U plus AT. U is equal to 0 when you throw it across. So as a result of it, it is 0 plus GT. GT over here. What is G here? G is acceleration due to gravity. Thus you see it's 9.8, which is a constant. So V should be proportional to T over here. When I say V is proportional to T, what kind of equation? It is nothing but equation of a straight line. So this is also incorrect. So this is the right one. Okay. Thus A is the right option.